Okay, what we're doing in this video is breaking down the u-tries from our equations, lesson 4, solving equations with the variables on both sides. So if you need a little extra guidance, watch this and I will hopefully answer any questions or help you out however you need with the u-tries. We're going to get started right with number 1. We're going to draw our line down the equal sign. We've been doing that. Look on our left-hand side, nothing to distribute, nothing to combine. Look on our right-hand side, nothing to distribute, nothing to combine. Variable 3x on the left, variable negative 2x on the right. When I can, like to move my variable, I say letter to the left, our variable to the left. So that negative 2x, I need to move it over to the other side. So when I move it over, I need to do the opposite operation. So I'm going to do plus 2x. If I do the opposite operation on one side, I must do it with the other. Gonna make sure to align it with my like terms. So 3x plus 2x will give me 5x. And that's all I did. So I'm gonna bring down my plus 20 and bring down that negative 15. It boiled it down to our two-step equation. So I'm going to put our 5x in the box, okay? How am I going to move over that plus 20? I'm going to subtract it. Hopefully from here you are smooth sailing because we've been doing these two-step equations, these last two parts, for a little while now. And then to get that x by itself, the opposite of multiplying by 5, to move over that 5, I do the opposite, which is to divide, and we get x equals negative 7. Not too bad for our first problem. Number 2, I look at that and I see, oh my goodness, I have parentheses on the left. So that tells me I need to take that 4 and distribute it to everything in parentheses on the left. And then I have a negative 2 with parentheses next to it on the right. So I'm going to have to distribute that negative 2 to everything in parentheses on the right. So 4 times 2x will give us 8x. 4 times 5 will give us a positive 20, so we'll write plus 20. Negative 2 times x will give us a negative 2x. And negative 2 times 5 will give us a negative 10. I check to see if there's any like terms. On the left, there are not. Can I simplify that left any further? No, I cannot. I check to see if there's any like terms or things I can simplify on the right, and there's not. But I do see a variable on the left and a variable on the right, and so I want to move all my variables to one side. I'm going to move that minus 2x over to the right, or it's on the right. I'm going to move it over to the left. And how I'm going to move it is I'm going to do the opposite since it's going over, and I'm going to add 2x. And I'm going to make sure I align it nice and neatly with the other x term. Sometimes people like to draw a line here, totally up to you. 8x plus 2x will give us 10x. We're going to bring down that plus 20, and we'll bring down that negative 10. We're going to put that 10x in a box. All right. How we move over that plus 20 outside of the box, if we need to move it over, we do the opposite operation. So we minus 20 on the left and we minus 20 on the right. We'll bring down our 10x. Negative 10 minus 20 will give us negative 30. And now we're going to divide both sides by that 10. And I'm going to write my answer right here. X will equal negative 3. Okay? Moving right along to number 3, I am already looking at that and I'm thinking, goodness gracious, there's lots of x's, but the one good thing is there's no distribution that we have to do. There's nothing with parentheses. So when there's nothing with parentheses, you want to, before you start moving things left and right, we want to look at our left-hand side and say, is there anything we need to simplify on that left-hand side? So do we have any like terms? And For all of these single x's, I'm going to just squeeze a 1 in front of them, so I know that's what their coefficient is. And I can say, okay, 5x plus 1x, it is on the same side. Those are the two things I'm combining on the same side of the line, so I keep the operations as is. 5x plus 1x is 6x. Then I will bring down my plus 4. Now I'm going to look to the left or the right-hand side. I keep mixing up my rights and lefts. Looking at that right-hand side, I see like terms that I can simplify. 1x minus 1x. So they're on the same side, so I'm going to keep the operations the same and just simplify. 1x minus 1x is 0x. And remember, when something adds to 0x, I don't end up writing it because 0 times x is just 0. So I'm going to end up bringing down just that 34 there. And so we thought we were going to have all this work and we had all these variables, but now right from there, it boiled down to our two-step equation. So I am going to put that 6x in a box. We are going to move over plus 4. Hopefully you are answering these, or you know the steps. If I were to say, okay, how do I move over that plus 4? Hopefully you can answer it or say it out loud to yourself that we're going to subtract 4. We're going to bring down that 6x. 34 minus 4 is 30. We're going to divide both sides. Whoopsie, got a little ahead of myself. Forgot to change my color. After a while, it just becomes habit, and you're just going to move through without even thinking. Divide both sides by 6, and we're left with x equals 5. Okay, number 4 has a lot going on. So I'm going to draw my line down my equal sign. I see on that left-hand side that I do have parentheses, so I want to distribute that 5. So that's going to become 5x, and then 5 times 3 is 15. And on that right-hand side, we see parentheses. And remember, that's like a negative 1 there. So that's going to leave us with negative 1x. And then that's going to leave us with plus 15. Negative 1 times negative 15 gives us a positive 15. We're not distributing to that 6x because it's outside of our parentheses. So we're good to just bring it down. All right, let's look at that left-hand side. Do we have any like terms? Can we simplify that left-hand side anymore? And hopefully you agree or you're answering no, right? 5x is the only x term and 15 is the only constant. Okay, now let's look at the right-hand side. Do we have any like terms that we can combine before we move things left and right? And the answer is yes. We have negative 1x plus 6x. Same side, simplify. Negative 1 plus 6 will give us 5x. And then we're going to bring down that plus 15. Okay. Now we're ready. We simplified the left, we simplified the right. We're ready to move over our variables so they're all on one side. So I like to move my variable from the right over to the left. So because that's a positive 5x, I want to get rid of it by subtracting 5x. And notice here, 5x minus 5x is 0x. So we normally wouldn't write 0x because anything times 0 is just 0. So 0 times x is just 0. So that's going to cancel out on the left-hand side, just leaving me with 15. And because I'm doing 5x minus 5x on the right-hand side, that's going to cancel out those x's on the right-hand side, just leaving me with 15. So remember, when we don't have a variable to solve for, we go into the concept of, okay, is this a true statement or is this a false statement? So I don't have an x to isolate here, but I have an equation. It says 15 equals 15, and that is true. And when you do have a true statement, that means that we have infinitely many solutions. Or you might see people say your values of x can be all real numbers. But what it's saying is any x you pick, any x you can think of, that's a real number. If you substitute it into this equation, it's going to work on the left and right. You pick x equals 5, it's going to work. You pick x equals 2, it's going to work. You pick x equals 2.5, it's going to work, right? So infinitely many solutions. Okay, the last two. Number 5. We are going to distribute. On that left-hand side, we have parentheses, so we have 2x and then 2 times -3. So 2 times x is 2x, 2 times -3 is -6, and then we're going to bring down that -7x. Now, some people might just keep going on that left-hand side and now simplify. Totally up to you. I like to get all my distribution out of the way. 3 times x on the right, 3 times 6. So that's going to leave us with 3x plus 18. Okay, now looking at that left-hand side, we do have some more simplifying to do. We have 2x minus 7x. We're going to combine them, same side, same operation, simplify. 2x minus 7 will give us -5x. We'll bring down that -6. And looking at that right-hand side, 3x and 18, they are not like terms. There is nothing else we can simplify on that right-hand side. So we'll just bring both of them down. Okay. Now we want to get our variables all on one side, so I'm going to move my 3x over to the left to join the -5x. It is currently a positive 3x, so I'm going to move it over by subtracting 3x, the opposite of adding, because we're moving over. -5x minus 3x will leave us with -8x. We have -6. Equals, and we'll bring down that 18. We boiled it down to a two-step equation. We're going to move over that -6 by adding 6 to both sides. So we have -8x on the left equals 24 on the right. And now, last but not least, we have -8 times x. There's nothing in between those. So the opposite of multiplying by -8 is dividing by -8. We're not switching the sign because we're talking about the opposite operation, not the opposite value of that. Okay? And so that's going to leave us, let's see if I can squeeze it here, x equals -3. Awesome, awesome. Lots of steps to that one. So as you'll see, all of these equations, they boil down to the same last couple of steps. We can always boil it down to those 2 steps, and then we isolate our variable. So let's do our last problem, number 6. Last but not least, I'm going to draw a nice long line down. If I look at that left-hand side, it looks to me like I have to distribute. I see parentheses and a number in front. So I'm going to distribute that 3 to everything in parentheses, bring down that 5x. So we're going to have 5x plus 3x. 3 times -4 will give us -12. And then if I were to ask you what we have to do on that right-hand side, hopefully you would recognize, oh, we have to distribute on the right-hand side as well. -2 to everything in parentheses. It does not go with that 12x because that is outside of the parentheses. So we will just bring that down. -2 times 2x is -4x. -2 times 3 is -6. And then I'm going to bring down the 12x. Now I'm going to look and say, okay, do I see any like terms on that left-hand side? We want to get that left-hand side as simplified as we can. I do. I see 5. Whoopsie, why is it doing that? So I see 5x and 3x. I can combine those, and that's going to give me 8x. It's on the same side, so we keep the operation the same. We just simplify, and we're going to bring down that -12. On the right-hand side, looking for like terms, We have negative 4x and positive 12x. Same side, simplify. Negative 4x plus 12x will leave me with an 8x. Bring down that negative 6. Now maybe from here you can see what's going to happen. If so, awesome. If not, we go about business as normal. We say, okay, we have our variables on the left and right. We want to bring everything to one side. I'm going to move that 8x over to the left. It's positive, so I'm going to subtract it. Because it's moving over, I do the opposite operation. 8x minus 8x is going to go to 0x, and 0x is just 0, so I'm not even going to write my x term there, so the x's go away or cancel on both sides. We bring down that negative 12 on the left, and we bring down that negative 6 on the right. Now remember, when our variables are gone, we are in an all or nothing sort of deal. Either every real number is going to work, or no numbers are going to work at all. And our trick for this is asking ourselves, do we have a true or false statement? So does negative 12 equal negative 6? And the answer is no, so that is false. And therefore, when it's a false statement, we have no solution. And you can write no solution, or sometimes we use that empty set, that 0 with a slash, signifying that there is no real number that will satisfy this equation, okay? So think of any x value, whatever you try to plug in, you will never find one that will make that left-hand side and right-hand side equal. So hopefully, if you needed some extra help, that helped you with those U-tries. We are going to continue on in our equations. Keep up the great work.